Hi, welcome back. Page 2 now. Okay, on number 6 we've got two rectangles, and Jim says the two rectangles are similar because 8 plus 4 equals 12 and 6 plus 4 equals 10. So what he's doing there is he's noticed that we just have to add 4 to each of these lengths and we get the corresponding length. Is Jim correct? Well, no. And quite often on these sorts of questions, when they ask you if somebody's correct, the answer is no. Not always, but most of the time. And that's because similar shapes don't work like that. So in maths, when two shapes are similar, it means that their lengths of corresponding sides are in proportion. Okay, so get rid of those. So what we're looking for when we've got similar shapes is that we multiply by the same thing to find the length of the corresponding side, not add. So here, to get to 12, I would want to times by 1.5. Does that work here? 6 times 1.5, that would give me 9, not 10. So no, it does not work. Okay, so we want to put something like no. The two side lengths should be multiplied. Just going to add in here by the same scale factor. There we go, something along those lines would be perfect, or just sort of indicating that it should be a multiplicative relationship rather than an additive one. Okay, number 7. We're told that these two quadrilaterals are mathematically similar. Work out the length of LP, so this length here. So what we're looking for first is a pair of corresponding sides that we can work out the scale factor from. And we have that here. And if you're not sure what this is, this multiplier here, you could just divide the second one by the first one. So 9 divided by 6 would be 3 over 2, or 1.5. Sometimes it can be useful to use a fraction. Most of the time on these sorts of questions, I think a decimal will suffice. Work out the length of LP, so we've got to do the same to this length here. What's 5 times 1.5? 7.5. Okay, length of BC, it's this one here, so we are dividing this length by the scale factor, and that would give us 8. Okay. Similar shapes questions get a bit harder when one of the shapes is nested inside the other. So here we've got a triangle, ABC, a large triangle, and we've got a smaller triangle which is similar on the inside. Now, it doesn't tell us anywhere that this is a similar triangle to the large one, but we know it is because the angles are all the same. That's one way to show that two shapes are similar. They obviously both share this angle here. Why is this angle the same as this one? Well, we've got parallel lines here, so that means that this kind of makes an F shape if you were to flip it upside down, and therefore these two angles are corresponding. And the same is true for these angles here. What I like to do on these questions is draw the smaller triangle to the side, try to just consider what's left as the large triangle, so this is a length of 10 centimeters now. So we've got 5.8. Five and 4. Okay. Just checking if we've not got any other information which isn't on the diagram. Calculate the perimeter of the trapezium DBCE. So DBCE, this medium here. So what do we not know that we need to know? We need to know the length EC and the length BC. Okay, so what we can do is actually use our corresponding lengths again. So we have this length and we have this length, and they correspond. So the scale factor is 10 divided by 4, or 5 over 2, or 2.5. Okay, so we're going to use that to work out this length BC by timesing 5 by 2.5. And that gives us 12.5. So I'll add that to the diagram. Okay, and then we're going to do the same for this overall length. So we're going to times 5.8. So I'm going to call this AC. 5.8 times 2.5. And that is 14.5. But we just want the length EC, so EC is 14.5 minus the 5.8 that we've already got up here. And that gives us 8.7. So the total perimeter is these things added together: 6, add 5, add 8.7, add 12.5. And that gives us 32.2. Okay. Thanks. I'll go through the next page on the next video.